As I mentioned before, I wanted to talk to you guys in another video about the compound inequalities, how we have and different from or. I talked a little bit about this with the solutions, describing again that if you have a value of 5 for an or, this 5 can only be in the section greater than 3. It can't be in the section less than -2. So we have this inclusive, non-inclusive. Let's think about all of the possible integers that could be between -4 and 6. There's not that many. We can have -3, -2, -1, 0, 1, 2, 3, 4, 5, and not including -4 and 6. So there's not really that many. I mean, there's infinitely many solutions, but if we're just talking about counting numbers, the negative and positive, the integers, there isn't that many. Now let's look at the or. We have -3 and we have an infinite number, but this is covering a lot more integers. So if we think of this space as like a club, okay? This is our club. We have a door here, we have a door here, and only certain numbers can get in. Here, our door is kind of on 2 different parts, okay? So we want to think of some possible numbers that could get into each one of these clubs. So let's call this the and club, let's call it the or club. So let's say you are the number, I don't know, +7. Can +7 get into this club? I hope that you answered no, because you can see that +7 is outside of this range. So let's say we're at a club, we're using the club like as in the dance club. There's a bouncer at the door, letting people in, not letting people in. 7 walks up, says, I want in your club, and the bouncer says no. Why does the bouncer say no? The bouncer says no because 7 is not less than 6. 7 is greater than -4, but remember the and restricts this scenario, restricts all the values that are greater than 6, actually including 6. Even if 6 wanted to get into the club, the answer would be no. Just like 7, poor 6 and 7 would be hanging out there, outside, being cold. Maybe they just go home or try to go to another club. So we see that in the compound inequality, and just because a number is greater than one of the numbers satisfies one of the inequalities, it has to satisfy both at the same time. Let's look at the or. The or is a little bit different. Instead of having all of the integers in between here, we have all of the integers except for that. So can -3 get into this or club? Yeah, it can. -3 gets into the club because it is less than -2. It doesn't also have to be greater than 3. In fact, it's impossible for any of these numbers to be in both places. Let's look at one more. I heard the bell. People are going to come in. Can 2 get into the club? And that would be no. 2 is here. It is not greater than 3. It is, or it is not less than -2, so it doesn't work.